All right. Today we're going to talk about operations on functions. We're going to take different kind of functions, linear, quadratic, cubic. We're going to add them together, subtract them, multiply, and divide them. So let's get started with adding. When we add two functions together, and also when we subtract two functions together, we're going to be adding and subtracting in like terms. So depending on where you are and what you remember, you might can look at these two functions that I have here. So g of x equals 3x plus 3, and f of x equals 2x minus 2. We might just look at it and go, okay, these are like terms. 1, 2, 3, 4, 5. That's going to be 5x. And 3 plus negative 2 is 1. Another option that you have, just so that I want to show you all the options possible, you can rewrite your functions right beside each other so that they are horizontal. And if you need to go back and underline things that are the same or highlight things that are the same, notice I underlined the 3x and the 2x, and then say I wanted to do the 3 plus the 2. So the 3x and 2x are like terms, and the 3 and negative 2 are like terms. Regardless of where you are, 3x plus 2x, that's going to be 5x. And 3 plus negative 2 is going to be 1. So the final answer, once I added these two functions together, final answer is 5x plus 1. So g plus f of x, that was the question that they were asking us. I will add those two together by adding and subtracting like terms. Same thing is going to be the case for g minus f. So I'm going to rewrite these right beside each other. This is my g function, and this is my f function. So I got those two functions together. Now, when you're doing subtraction, sometimes you have a higher chance of messing up on your sign. So I like to do keep, change, change. So I'm going to keep or keep, change, flip, depending on what you remember. So you keep the first function, change this to plus, change this sign, change this sign. So we keep the first function, which is 3x plus 3, change the subtraction to addition, and change the sign of everything after the subtraction sign. Now, you only do this for subtraction, and you only do it if you feel like you need this extra step, which is perfectly fine. So now when I add these together, it's now an addition problem, which most people are better at. 3x plus negative 2 is 1x. Don't have to put the 1 there if you don't want to. It's not necessary at all. And 3 plus 2 is 5. So if you had x plus 5, we're speaking the same language. It's the exact same thing. All right, now let's move on to multiplication. We're still working with the same function. So this is going to be g times f. So if I do g times x, we have some different methods. We can do the distributive property, or we can do the box method. I am a box method kind of person, so I set up the box here. It's going to be a 2 by 2 box. 2x minus 2. And there we go. So I use the same functions that I started with. G of x is 3x plus 3. F of x is 2x minus 2. Make sure you take your signs if you're going to do the box method. So now I'm going to multiply this out. So 2x times 3x is 6x squared. 2x times 3 is 6x. Negative 2 times 3x is negative 6x. And negative 2 times 3 is negative 6. Now when I multiply this, I'm going to combine like terms. 6x squared is the only square term in the problem. 6x minus 6x cancel out and make 0. And then I have negative 6. So when I multiply these two functions, 3x plus 3 times 2x minus 2. When I multiply that out, that gives me 6x squared minus 6. And the last one that we're doing, again, these are the two functions that we're doing for all 4 operations. We added them together. We subtracted them together. We just finished multiplying, and now we're about to divide. When we divide them, we're not literally going to divide. In Math 3, we did polynomial long division and synthetic division, but we're not going to do that for this particular problem. We're just going to put them on top of each other, so to speak. So we have our g function, which is 3x plus 3. I see that up here at the top. It says 3x plus 3. And I have my f function, which is 2x minus 2. So 3x plus 3 is my numerator because that's what the problem told me to do. and 2x minus 2 is my denominator. Again, not literally doing anything right now. So synthetic and long division are out there, but we don't have to do that. We do, however, need to figure out what my domain cannot be. So what can the denominator not be? Because you know that we cannot divide by 0. If we try to do 5 divided by 0 or 7 divided by 0, that's not going to work. It's going to be undefined. So we need to take our denominator, set it equal to 0, and figure out what the denominator cannot be. So if I add 2 to both sides, remember solving equations, opposite operations, add 2 to both sides and divide, okay? My denominator cannot be equal to 1. So all of this is the answer. So recap, we had these two functions that we started with. We added the two functions together. We subtracted the two functions together by adding or subtracting like terms. We did the box method to help us multiply. In the next example, I'll review the distributive property for those of you that like to do that way. And then for dividing, we just put the two functions on top of each other, but we do need to find where our denominator cannot be because that'll cause a hole when we start the graph. Hole is in H-O-L-E, so it'll create a hole. Okay, let's do another problem. So now we have two new functions, but we're still going to go through. We're going to add these two functions, subtract them, multiply, and divide them. So negative 3x squared plus 3x is my first function, and 2x plus 5 is my second function. Again, you might can look at these and see, okay, nothing goes with the x squared, bring it down. 3 plus 2 is going to be 5x. Nothing goes with the 5, bring it down. But there's also nothing wrong with you just recopying the two functions that you're working with. And then we'll go through and add our like terms. As I previously said, negative 3x squared, there are no like terms that go with that. 3x and 2x go together, that gives me 5x. Nothing goes with the constant, bring it down. So your final answer is negative 3x squared plus 5x plus 5. So that is your final answer for G plus F for x. Now over here, subtraction, same thing. Let's rewrite the function that we're working with. This time it's a subtraction problem. I like to keep change. It lessens your chances of messing up on the sign. So we keep the first one, don't change anything about it. Change subtraction to addition and change the sign of everything after the subtraction sign. So we keep the first function, change subtraction to addition, and then change the sign of everything afterwards. Now we go through combine like terms. Nothing goes with the x squared term. We just bring that down. 3x plus a negative 2x is going to give me 1x. Again, you do not need to put the 1 in the front. It's not necessary at all. It's just there in case you need it. And then minus 5. So just like that, we have added and subtracted these two equations right here. Or excuse me, these two functions. All right, now let's multiply these two functions. So in the first example, I showed you the box method. So for this box, it still would be a 2 by 2 box. If you like to do that, that's fine. But I also want to show you how to do the distributive property. If you do the distributive property, you take the first term here, which is negative 3x squared, and you multiply it by the second function. And then I have the positive 3x, and I multiply by the second function. So this is the distributive property. So negative 3x squared plus 3x was my f function. 2x plus 5 is my second function. I go through here and I multiply. Negative 3x times 2x is negative 6x to the third. Negative 3x squared times 5 is negative 15x squared. 3x times 2x is 6x squared. And 3x times 5 is 15x. So we did the distributive property. So if you need to put your arrows at the top so that you can keep track of what you're multiplying by, there is nothing wrong with doing an additional step as long as it leads you to the correct answer. Now I need to look and see if I have any like terms. Nothing goes with the cubic term, so I just bring that down. These two terms go together. So that's going to give me negative 9. And nothing goes with my linear term, so I just break it down. And last but not least, we're going to divide these two functions. So again, when we're dividing, let me zoom out a little bit so we can see our functions here. We're just going to put them on top of each other. Not literally doing any kind of dividing. We're just going to stack them on top of each other. So it says F is going to be our numerator and G is going to be the denominator. Make sure when you're doing these, you follow the order. So for subtraction, if it said F minus G, that would give us a different answer than G minus F. For division, if it told us to do G divided by F, that would give us a different answer than F divided by G. But in this case, we're going to stick to F divided by G. So if I do F divided by G, my F function is negative 3x squared plus 3x. And my G function is 2x plus 5. Now, we're not going to do synthetic division or long division like we would back in Math 3. So we're just going to stack them on top of each other. However, we do need to figure out what number my denominator cannot be. So we take the denominator, always set it equal to 0, and that'll give us what our denominator cannot be. Subtract 5 from both sides and divide. We got a fraction, but that's okay. So for this particular example, x cannot be equal to negative 5 halves. So we took our denominator, we set it equal to 0, subtract 5 from both sides, and divide by 2. So x cannot be equal to negative 5 halves.